Hey, good afternoon, everyone. My name is Tom Douglas. I'm with RACO. Thanks for joining us today on our webinar about the fundamentals of noise. Leading our webinar today is Lee Hager from 3M. Lee is, I think he's pretty close to being on our 5-timers club. He's helped us out a number of times here with some webinars and seminars, so we greatly appreciate his time and his input. For those of you who don't know Lee, he's got over 25 years experience working as a certified occupational hearing conservationist. Consulted a number of Fortune 50 companies, served on a number of councils, including the Council for Accreditation in Occupational Hearing Conservation, and served for a while as the president of the National Hearing Conservation Association. So hearing is his world, and I don't know many people know much more about it than he does. Couple of housekeeping items. We will be recording this webinar, so if you'd like to watch it at a later date or you want to pass it on to a friend, we will make that available at our RACO website at raco.com/training. Other part of it, we have a lot of people joining the webinar today. If you have questions that come up, please use the little question tab in the lower right-hand corner, or upper right-hand corner, rather, of your screen, and we'll be sure to get to those towards the end of the presentation. So without further ado, Lee, I'm going to pass it over to you. Go from there.
Well, thank you, Tom. I certainly do appreciate it, and appreciate the opportunity to talk to you folks about what has been kind of my life's work in noise and hearing. Our strategy today is going to be to cover this kind of from a 30,000-foot view, give us an overview of what's going on, what some of the legal requirements might be, what's the hazard we're dealing with, and those kinds of things. But before we do that, I also wanted to remind you that our partners at RACO have a pretty substantial social media presence. So what you see here is how to get to the RACO folks. Twitter, LinkedIn, the website, the YouTube channel, which is a very powerful resource for training videos, as a matter of fact. So absolutely, RACO is everywhere, and you can certainly find them wherever it is you want to go.
Thank you for that friendly plug.
Not a problem, Tom. My pleasure. So my contact information is up here. As Tom indicated, I am a hearing conservation specialist for that little tiny St. Paul-based 3M company. Very fortunate to work for a company that is large enough to afford me to focus on just one part of the anatomy instead of covering everything in the world. So what we're going to be doing today is talking about noise, talking about hearing, and talking about some of the basics as to the things we can do to actually do a better job with things. Of course, we are required by our legal staff to put this slide up. Please read and pay attention. What I'm going to be telling you is the best of my knowledge, but boy, our lawyers aren't going to stand by it. Let's put it that way. Okay? So that's me. That's where I was. That's what I've been doing, and that's the area that I've been working in. I've been very fortunate to be able to focus on noise and hearing exclusively since the mid-1980s. Seen a number of things develop, but it still kind of surprises me as we go along that there are an awful lot of folks who say, you know, I know this noise thing is something I need to be dealing with, but, you know, I just don't know how to get my arms around it. I don't know how to get started. So that's really what we're going to be focused on today. How do we get the best out of what we've got? How can we operate programs that are going to provide some benefit to us? Now, here's the takeaway message from the very beginning. I'm going to start right out with kind of the good news and the bad news here. Whether you are aware of it or not, we live in a pretty darn noisy world. You can kind of see the sound levels and the various sources of those sounds, ranging from about 10 decibels to about 120 decibels here. And what I would like to do is, starting about with the red ones there, starting about at 80 to 85 decibels, take a look at those. Think about how many of those are in your life. Think about how many of those things are in the life of the people that work with you and work for you. We absolutely live in a noisy, noisy world, and the risks to hearing come from all over the place. I mean, it's lawn and garden equipment, it's on the job, it's a hammer drill, it's a riveter, it is at Tom Petty concert I went to a couple of years ago, from which my ears are still ringing. I mean, there's lots and lots of things in the world that are going to make noise. The risk to your hearing is going to start right about where this chart turns red. When sound levels on a regular basis get up to about 85 decibels, that's when things start to get risky. And yeah, there are a number of things that get even louder than that. The one at the very top of the stack here, the 12-gauge shotgun, I tell you, if you ask hearing healthcare professionals, they will tell you that the leading non-work-related cause of noise-related hearing loss is going to be recreational use of firearms. I mean, they are all over the place. We make a ton of noise in the world that we live in. We make an absolute ton of noise in the world that we live in, without a doubt. Okay, so we live in a noisy world, but so what? I mean, why is this a deal to us? Well, noise actually brings a number of complicating issues along with it to the rest of your life. Poor communication. When noise gets in the way of being able to clearly communicate, being able to have that spoken language, verbal communication that sets us apart from the other animals, that's a key aspect of what noise can do to hurt us. We rely on sound, we rely on our hearing as a significant source of entertainment. I mean, one of my favorite things in the world to do is still to listen to music, and you got to have some healthy ears if that's going to be happening for you. There are a number of published studies that indicate that exposure to noise increases stress level. Now, whether this relates to the things above, whether it's a poor communication increasing stress, whether there's just an inherent whole body response to high sound levels that manifest as increased cortisol or stress levels. Lots of noise increases stress, and we know what increased stress can do. Strained relationships, the challenges that are struck with trying to communicate with somebody who might have a bit of a hearing loss, especially in a noisy environment, can be very, very difficult. I'm kind of a personal survivor of this with my stepdad having a moderate noise-induced hearing loss that he developed over time from noise exposure on the farm. And I tell you, it becomes a very, very difficult thing when it gets to be 7 o'clock on a Thursday night, and Dad's watching Wheel of Fortune in the living room at about 114 decibels, while Mom's in the kitchen watching Wheel of Fortune at about 70 decibels. I mean, hearing loss and noise putting barriers between people, straining relationships, making those things difficult. Challenges at work related to some of the things above, related to the increased stress, related to the inability to understand spoken language, verbal communication, absolutely can be a challenge. Irritability. Now, whether this relates to the things on the list or whether this is a function in and of itself from exposure to noise is a good question. But irritability absolutely goes right hand in hand with noise and hearing loss. Annoyance is going to be a significant issue. Fatigue is going to be a significant issue. Bottom line is, too much noise can do irreversible damage to your ability to hear. Your ability to hear spoken language, your ability to hear warning signals, your ability to hear instructions, your ability to use your sense of hearing to function in the world that we live in. That's what we're really shooting for here. What we're trying to talk about in the context of our talk today is how can we manage the noise that we live in such that it does not manifest as a hearing loss in our ears? How can we manage noise to prevent hearing loss? That's really going to be our focus for today. So what is it that noise does to your hearing anyway? Well, your hearing system is actually a rather sophisticated rig. It starts on the outside of your head with what we normally think of as our ear, something we call the pinna, that little flap of skin that holds your glasses up, specially designed with hills and valleys and curves in it to gather up the vibrations from that jackhammer or from whatever it is out there that's making noise and channel those vibrations right down the ear canal. That's the tube that you see between the pinna and the next part of the hearing system. Now, the dividing line between that outer ear, the pinna and the ear canal, and that middle ear is the eardrum. You see that growing right across the end of the ear canal there. That's kind of the magic spot where sound gets changed from being something that's airborne vibration to being something that's mechanically transmitted. Once we get it into a mechanical transmission At that point, we can actually move it on down to the rest of the rig for processing. So we start out with airborne vibrations, change them at the middle ear to mechanical vibrations as they travel through those three little tiny bones that you see attached to the eardrum. These three guys right here, smallest bones in the human body. Now the last of those bones connects into a fluid-filled organ that actually lives inside your skull, inside your mastoid bone, as you can see here. That's the inner ear. Now that fluid-filled organ comes in two different parts. The three big loops you see up here on the top is what lets you walk around standing up. That is your vestibular system, or your balance system. The snail-shaped guy down here on the bottom is what you hear with, and that's called your cochlea. Now you can see that as the vibrations start out here, picked up by the eardrum, they go through the bones, they get transmitted into the fluid in that cochlea. Now the fluid, the vibrations in the fluid cause these specialized little hair cells, these guys right here, to flex up and down. As they flex, they release electrical impulses, go right down this big yellow nerve. It's probably not yellow inside your head, but it's certainly a nerve inside your head. And those electrical impulses get sent down to your brain for processing. So this diagram, if you will, has a couple of interesting stories to it. Number one, your sense of hearing is a pretty darn amazing thing. It is sophisticated, complicated. I mean, we transfer energy from airborne to mechanical to pneumatic to electrical, or to hydraulic and to electrical. But the real bottom line is, you know, what you hear with is actually your brain. Until it gets to your brain, it's nothing more than ons and ahs, nothing more than electrical impulses. So, if that's what the ear does, if that's what your hearing system is designed to do, these pictures kind of give you a sense as to what noise can actually do to that system. Over on the left, you see an actual microscopic photograph of what those hair cells look like. Those are actually, honest-to-goodness, hair cells from a photograph taken of the inside of the cochlea. Everybody's standing up, they're doing their job, they're looking pretty good. But if you take that ear, expose that ear to too much noise for too much time, look what happens in the panel over on the right. Those hair cells are disappearing. They're gone. They're dying off completely. And the worst of it is, once that damage is done forever. The hair cells inside your cochlea cannot regenerate. They don't grow back. That's why noise-induced hearing loss is permanent and irreversible. And why what we're talking about today with preventing that hearing loss is the line of defense that's going to make the most sense for us to be able to keep our hearing safe, keep it doing what it is that we need to do. Before noise, after noise. That's a graphic depiction of exactly what noise is going to do to your ears. Too loud for too long, that's the damage that gets done. Okay, so if noise is such an evil thing, how much is too much, and how can I tell? Well, regular exposure to noise levels above about 85 decibels has got the potential to damage your ears over time. Okay, so how loud is 85 decibels? How do I know if I'm in a situation where the noise levels are going to be posing a risk to my hearing? Well, there are certainly a couple of ways that you can tell. 3M manufacturers and Rayco distributes for us a whole line of equipment designed to do exactly that. We have noise measurement equipment, sound level meters, noise dosimeters, things that are specifically designed to measure decibel levels, sound levels in the air. There are applications for your smartphone that can be of assistance in determining how loud things are. Let me give you a grain of salt with that. Recent study that I actually just read yesterday indicates that the accuracy of the sound level meter applications on the cell phones not really up to par, primarily because of the variability in hardware and because of the variability in the way the apps are put together. So the apps, the sound level apps for your smartphone are very cool. I got one without a doubt, but I wouldn't want to rely on it to be able to make final decisions. There are a couple of non-electronic ways you can tell whether you're being exposed to that extreme level, to that 85 decibel, where the risk of hearing damage starts to kick in. The first one there, tinnitus or tinnitus, you can use either pronunciation that you want to, is that situation where you have a ringing sound or a rushing sound in your ears that you hear that other people can't. Now, my wife has accused me of that being the voices in my head. I promise it's something different than that. Sometimes when you walk out of a noisy situation, you'll hear that ringing sound in your ear. You'll hear a sound in there that sounds like a tone or a ring or a phone or a rushing sound. Well, that's an indication that you may have done some temporary damage to that hearing system. That is an indication that that noise that you were just in was too much, and a steady diet of that kind of noise level can pose a risk of permanent hearing loss. So if you're walking out of a noisy place, your ears are ringing when you walk out, that is a message. That is a message that that was too loud. You can also tell while you're in the noise if you're getting to that 85 decibel level. Simplest way to do that is what we'll call the arm's length rule here, okay? Imagine, if you will, that you're standing about arm's length away from somebody that you want to have a conversation with. If you've got to shout to be heard, if you have to raise your voice to be heard at arm's length, in all likelihood, the sound levels around you are getting to be 85 decibels or greater. So just kind of stick that one in your pocket for the next time you're in a noisy situation. You know, going to the ball game, going to the cocktail lounge after the ball game. You know, going to the Tom Petty concert, for goodness sake. If you're standing arm's length away, you got to raise your voice to be heard. Those levels are probably going to be above 85 decibels. So OSHA, of course, has a set of rules or a set of criteria that are going to govern noise exposure in the workplace. For those of you who are geek-oriented like I am, 29 CFR 1910.95 is the Federal Hearing Conservation Amendment. Pretty clearly lays out the steps that you need to go through when you have noise levels that exceed 85 decibels in the workplace. Exposure above 85 requires you to manage an effective, ongoing hearing conservation program. OSHA didn't really tightly define what effective meant. Ongoing is pretty self-explanatory, but there are certain steps that are going to be required if you got to put a hearing conservation program in place. First step is going to be, of course, to figure out how loud the place is. We'll do some noise measurement so we can determine the kind of noise that people are exposed to on a regular basis. We can determine from there who needs to be in the hearing conservation program and all the other steps that go along with that. The hearing conservation program requires annual training on some specific things: the effects of noise on hearing, the types of hearing protectors, advantages and disadvantages of each type, and something that will actually point to the next item on the list, the purpose and techniques for hearing testing. Now, annual hearing testing is required for people who are exposed above 85 decibels on a time-weighted average. That's an average over a course of an entire workday. There are the protocols that are used to do that hearing testing are pretty clearly outlined in the law, and there are a number of resources that can help you figure out exactly how to get that done. A large number of companies will provide that as a service. We'll bring in testing equipment, testing vans, and be able to do that part of the program for you. But an annual hearing test is part of the hearing conservation program. We're required to offer hearing protection devices, a suitable variety of hearing protection devices, as a matter of fact. Typically, that's going to mean a couple of different styles of ear plugs and an ear muff. And the protection offered by that hearing protection has to be sufficient to keep people's net exposure, the noise level getting through underneath the earplug, to a safe level. Protect people down to either 85 or 90 decibels, depending on which side of the law that you're actually looking at. But that hearing protection's got to be carefully selected so that A, people use it, B, is comfortable, and C, it knocks out enough noise to keep people safe. Like most OSHA things, of course, we're required to keep some records as well. We have to keep those hearing tests in line with all our other medical records. Our recommendation is duration of employment plus 30 years. The noise measurement records are required to be kept for 2 years. In today's day and age, I can't see any reason not to keep the noise measurement records exactly the same way you do the hearing testing records. So there are a variety of things that are required that you need to keep track of make sure that the records are in place, that the program has been in place, the program has been effective, and we're doing what we can to prevent hearing loss in the noise-exposed workers. Okay, so this is the problem. Noise is the deal. How can I keep my people safe? What do I need to do to effectively keep people's ears from bearing the effects of too much noise? Well, number one, we need to, as much as possible, reduce the noise levels in the workplace. There are a variety of different ways that we can do that. There are a number of simple controls that we can apply that will reduce noise levels getting into people's ears. Something like the barrier picture that you see here, a regular maintenance of equipment that will keep cutting tools sharp and lubrication where it's going to be necessary and appropriate. Control of compressed air is going to be an absolutely huge part of the noise control efforts in most facilities. Those kinds of simple maintenance-based controls can go a long way to reducing noise levels. There may be situations where you get into a noise source that's more complicated, it's more sophisticated. Don't be afraid to call in help. There are a variety of folks out there who can come in and provide some assistance to be able to effectively control noise in whatever it is that's making noise in their workplaces, causing people's overexposures. We can also employ administrative controls. Basically, administrative controls kind of come in two parts here. Number one, we can move people in and out of noise such that we reduce the duration of their exposure. We reduce the amount of time they're actually being exposed to noise. We'll take, if you will, that noise burden generated by one machine, and maybe we'll split that across 3 or 4 people over the course of a shift, so nobody's got to deal with it for an 8-hour day. That is absolutely an acceptable administrative control. It's got to be documented, and it's got to be well measured and well designed, but that is certainly an option. We can also use an administrative control in managing time, the time of operation of some noisy equipment. Well, I tell you, if we've got one piece of noisy equipment in the plant, is there any way that we could arrange to run that thing on midnights when there's 3 people in the plant instead of running it during the day when there's 300 people in the plant? Well, you just take 297 people and remove them from the exposure to that noise hazard. So managing time and managing people can both be effective administrative controls. Our last line of defense, of course, is going to be personal protective equipment. And of course, we have to employ personal protective equipment up until the time we get our effective engineering and administrative controls implemented and in place. Earplugs, earmuffs are both reasonable options, basically both set up to block noise from the outside from getting down the ear canal to the eardrum to the rest of the system that we talked about. Earplugs do it by completely filling the ear canal. Earmuffs do it by essentially putting a cover over the top of the pinna that blocks the noise from getting in that far. Now, one caution that it's important you understand about the use of earplugs and earmuffs: we are required to evaluate hearing protectors under a protocol developed by the Environmental Protection Agency and come up with a number for each hearing protector that we market called a noise reduction rating. Everybody who makes hearing protectors has to evaluate their devices to develop a noise reduction rating. The noise reduction rating is designed to be an estimate of the amount of noise being blocked from the outside to the inside by use of the device. So if I've got an outside noise of 100 and I've got a noise reduction rating of 20, I should have a noise in my ear canal of 80. That's the way the process is designed to work. What we've found over time, though, is that there is so much variability in people, so much variability in physiology, in the way your ears are put together, the size, the shape, and the contours of your ear canal, your ability to use the hearing protectors that are being provided to you, the training that you get in use those hearing protectors. All those things are such huge variables that they may cause that noise reduction rating to be not really relevant, not really pertinent to the amount of noise being provided to an individual worker. OSHA's got ways that they deal with this, but the caution for you is, you know, you look at the noise reduction rating, man, I would not rely on that number to save somebody's hearing. I just don't think it's going to be reliable. There are other ways to get to that, but the noise reduction rating may not necessarily be realized in everybody's ears who's using the devices. Let's talk a little bit about selection of hearing protectors. I mean, which one is going to be best? I mean, I hope that you're all taking my message to heart here. You want to do the best job that you can to reduce and eliminate noise-induced hearing loss in your workers. So you want to use the best hearing protector out there, right? Well, I would love to be able to stand up here and tell you it's that big red 3M earmuff on the top of the page, but that would be nonsense. The best hearing protector is a hearing protector that an individual worker who's working in noise is willing to use every time that they go into that noise. The best hearing protector is the one that's best tolerated, best adopted, best used, best accepted by the employees working in noise. So because of that, there are factors other than the noise reduction rating that we need to take into consideration when we're selecting hearing protectors. We need to get protectors that are comfortable. I mean, the biggest deal, the biggest variable is going to be the comfort of the hearing protectors. It's critical to have devices that are well tolerated, that will go in your ears. But in combination with that, we need a hearing protector that's going to fit properly. For a large-sized ear canal, we need a large-sized earplug. For a small-sized ear canal, we need a small-sized earplug. For a small-sized head, we need a small-sized earmuff. We need to be able to select devices that are appropriate for the people that are going to be using them, and indicate and to find a way to get devices into their hands that are going to effectively block the noise. Fit is going to be important. It's also important to keep in mind that we don't use earplugs by themselves. We don't use them in isolation. I mean, we're using hearing protectors in combination with safety glasses, with respirators, with hard hats, with lots and lots of other pieces of PPE and things that we have to use on the job. So as we select a hearing protector, we need to think about that. Oh, geez, you know, maybe the red earmuffs on the top of the page aren't necessarily the best choice for somebody who's also got to wear a hard hat. Those things are never going to go underneath the hard hat and be comfortable. Well, we've designed a version of that that actually fits into the slots on a hard hat and will accomplish that fine. But we need to think about that. As we select hearing protectors, we need to select hearing protectors that are going to be compatible with the rest of the equipment that we're going to be using. In a lot of cases, it's very important for us also to think about the ease of use of the devices. In the left hand of what you see down here in the two hands in front of the screen, these guys right here, or in the left side, these are all compactable roll-down foam earplugs. The strategy here is that we take these devices, we roll them down so they're small enough to fit in the ear canal, the hole in the side of the head. They'll expand to fill the whole ear canal and thus be blocking noise. Now, if you're going to be putting earplugs in and leaving them for 3 or 4 hours, these can be very comfortable. They're very well tolerated. As you can see, they come in a variety of shapes and sizes. That could work very, very well. However, what do you do with the guy who's going to be in and out of a noisy area in 10 or 15 minutes? Maybe something like a pre-molded earplug or a push-in style earplug that goes in and out easier would be a better choice for that individual kind of worker. Think about the logistics of use. Think about how the devices are going to be used as we're making our selections. These guys over here on the subject's left hand and our right, definitely going to be the least expensive selection. But these guys over here on the left are reusable. They're washable in a lot of cases. So as we think through the process, what we're going to select for hearing protectors, it's important to keep all these things in mind. How the devices are going to be used, who's going to be using them, what they're going to be using them for. That can help us a lot to kind of guide us down the road to get us into something that is going to be most effective for our workers. Well, we do have a couple of minutes here. If any of you have any questions, feel free to throw those into the chat world. I got a little chat window in your on your display here. It is a noisy world without a doubt, and it's important that you keep yourself safe out there. Probably with something other than your fingers in the tips, your fingertips in your ear canals, without a doubt.
Hey Lee, quick question. If somebody does have some concerns at their facility and they want to do a hearing conservation, I guess, survey, is there any kind of certification that's needed to be able to do that sort of survey if they want to do it themselves?
No, there's no certification required to do noise measurements. The Council for Accreditation in Occupational Hearing Conservation, CAOHC, actually has an online training course that shows you how to use different types of equipment to be able to get the results that you're looking for. So no certification is required, but looking for some support from either CAOC, American Industrial Hygiene Association, or your friends at RACO can provide you some support as well in selecting the right instrumentation, guiding you down the road to how do you get the noise measurements done.
See if we got anything else rolling in here. Here we go. Got one here real quick. Explain the operation of the noise dosimeters. Someone's looking and wants to explain the operation of the noise dosimeters. Not sure exactly what they're looking for.
Yep, that actually might be a pretty good segue for us here.
Okay.
3M and RACO are going to be working together on some more in-depth seminars. We're actually sponsoring a full-day seminar on noise measurement, including operation of sound level meters, dosimeters, and octave-band sound level meters. A session in Bensonville at the end of the month, and a session in Oconomowoc, Wisconsin at the end of the month.
That's very true.
Those are face-to-face opportunities to be able to really get hands-on with the equipment and get that stuff moving forward. Now, in the absence of something like that, again, I would recommend that you give a careful read of the owner's manual on the device that you got. If you have questions, feel free to contact the manufacturer or contact RACO or contact me. We'll do our very best to help get the process moving forward. Most of the information that you need to be able to operate the devices should be in the quick start guide and in the documentation that comes with the dosimeters.
Yeah, and since you brought it up, Lee, yeah, we'll bring it up right now before we get we got a few other questions to get to. Yeah, exactly at Lee's point, we're doing a free seminar, all-day seminar. We'll be doing one on Tuesday, June 28th, and that will be in Oconomowoc, Wisconsin. So if you're interested in attending, you can email me at tom@raco.com, and we'll get you the sign-up information. And then we'll be doing it again on Wednesday in Bensonville, our Bensonville office. Again, you can email me at tom@raco.com. I can get you a few more details about it. Typically a 9 to 4 seminar. We'll spend some more time, like Lee was discussing, some of the OSHA regulations, but then there's a good section of it where we'll actually get hands-on with a lot of the dosimeters and sound level meters and get a little more in-depth. So those are new to using the equipment. So a couple other questions have popped up here. Someone's asking about the difference between an L average and the TWA, or the time-weighted average, when reading a dosimetry report.
That's a great question. The L average absolutely purely reflects average sound level over the measurement period, over the period of time. TWA, on the other hand, accumulates over time, just as kind of like noise dose does. TWA and dose accumulate in the same kind of way. So you begin the day with a TWA of 0. You begin the day with no noise exposure whatsoever. And as the day progresses and you become exposed to noise, you increase the time-weighted average over time. At exactly 8 hours, the TWA and the L average value should be the same. If a shift were to exceed 8 hours, the TWA is likely going to be greater than the L average. So average, L average is pure average sound pressure level over time. TWA takes time into account. It begins with 0, and accrues or accumulates over the course of the day.
Perfect. Somebody's asking about how vibration can affect hearing loss.
Great question. Noise, of course, is vibration, but vibration runs in a huge range of frequency and intensity. All the way from things that are so high-pitched that our dogs can hear it and we can't, to things that are so low-pitched that they feel like the ground moving under your feet instead of like sound. There are some studies that implicate whole body and hand-arm vibration as possible potentiators for noise-induced hearing loss. Now, there are some studies that indicate if someone is exposed to an excessive amount of vibration, of whole body or hand-arm vibration, that you may wind up seeing more hearing loss than you would anticipate from the actual audible noise that somebody works in. I don't know that there's anything definitive on that yet. I know there's ongoing research. I'm not aware of anything that I could absolutely point to and say, yes, this is the Bible, this is the facts, this is the way it works. But there is some evidence that exposure to whole body and hand-arm vibration might make a system more susceptible to the effects of noise damage.
So this kind of leads in a little, we were discussing the military before we jumped on here, but we got someone's a police officer here and says his officers spend about 4 hours per year on the firing range to qualify with their sidearms, and said they are required to wear hearing and eye protection while on the firing range. As far as time-weighted average, would this group of employees be required to be in a hearing conservation program?
There are actually two answers to the question. The first answer is going to be a question. What other things are those officers involved with in the course of their normal duties, and do any of those other activities entail any kind of noise exposure? If the answer is no, basically the only noise exposure these people get is 4 hours a year on the firing range. It is likely that the overall exposure would be low enough that you might be able to avoid having a hearing conservation program. However, the way that OSHA views their limit for noise, their 85 decibel action level for noise, they don't care about how many days a year this happens. They consider it to be like a speed limit, okay? When I'm driving down the road and the cop pulls me over, he doesn't care that I've just been going, 68 miles an hour in a 70-mile-an-hour zone for the last 200 miles. What he cares about is that the instant that he caught me on his radar, I was doing 85. So it's a snapshot in time, if you will. And the snapshot that OSHA sees will be the snapshot that OSHA will make decisions on. Now, add to those factors the nature of the noise exposure that's involved with weapons fire. Weapons fire is highly, highly hazardous to hearing. Hearing protectors can be very effective. Hearing protectors can do a great job of knocking down the noise, without a doubt. But it's a difficult issue to try to figure out whether or not we need a hearing conservation program for these folks. Very short duration of extremely high sound exposures. We don't know what goes on the rest of the year. Boy, it's a tough call. It is a very, very tough call indeed. Now, there are some jurisdictions, depending on where you are and what you're doing, that have hearing requirements for fitness for duty. And in a lot of cases, you can roll a hearing conservation program into that fitness for duty hearing test, part of that fitness for duty physical. You can kind of tie the things together and make sure that all the ducks are in a row here. I mean, there are hearing requirements in a lot of jurisdictions across the country where an officer's got to be able to hear at a given level in order for them to continue to do their job. So a couple ideas there we might be able to knock around. I wish I could tell you that, no, 4 hours a year you don't have to have a hearing conservation program. But man, if OSHA shows up in that 4 hours, then they will probably write you up for not having a hearing conservation program. That's the nature of the speed limit approach to the way they deal with it.
Kind of circling back to the L average versus the TWA. So for clarification, if you were performing a survey for less than 8 hours, then you should use the L average number rather than the TWA?
Exactly right. Durations of less than 8 hours, you should use the L average. Durations of greater than 8 hours, you should use the TWA.
Perfect. Question, if you have an employee that already has some hearing loss, how do you choose the best HPD for them as to not isolate them from the environment completely?
Oh, great idea. That's a very, very good question. OSHA has published a couple of safety and health information bulletins, SHIBs, on selection of hearing protectors for hearing impaired workers and managing a hearing conservation program for hearing impaired workers. I would strongly recommend that you start there. They're short documents, but they're very well written and cut right to the heart of the matter. How do we deal with folks that have got some hearing loss? Now, there are a couple of technological considerations in this specific situation. Number one, does the employee wear hearing aids? Well, a hearing aid is not a hearing protector by law, okay? A hearing aid is not a hearing protector. Whether it's turned on or off, doesn't matter. A hearing aid is not a hearing protector. And you are required to test the employee's ears every year and provide them with hearing protection devices if they're working in areas that are going to be above 85 decibels. There are some new technologies that can help. There are both ear plug and ear muff models, electronic devices, if you will, that essentially have microphones on the outside of the device, picking up environmental sounds, picking up the ambient sounds, bringing the ambient sounds through the device, but processing the ambient sounds so that the output that goes into the ear canal is never at an unsafe level of sound. Typically going to be limited to a high of about 82 decibels. Those technologies have proven to be pretty successful with some folks with noise-induced hearing loss, or with some folks with hearing loss that are working in noise, excuse me. So there are certainly some answers out there. The electronic ear muffs might be an option. If somebody wants to leave their hearing aids in, we may look at an ear muff with an extremely large volume. The real big ear muff cups can sometimes provide a little bit better attenuation and might reduce the amount of feedback that's being produced when you cover up a hearing aid with an ear muff. The bottom line is you still got to have the hearing impaired guy in the program. You got to give them a hearing test. You got to provide them hearing protectors. But on a case-by-case basis, boy, they really need to be evaluated to see if any of these technologies might be able to help out.
Excellent. A little bit of the measurement level. What's the purpose of the peak value LZPK in the decimeters, and what standard value should we compare these values to?
Okay. We measure noise using a set of parameters that have been developed over time by the scientific community and adopted by OSHA, where the amount of energy in a given noise source is kind of smoothed out, evened out over time. We call that a slow response sound level meter. And that slow response sound level meter does a very good job of communicating average sound levels and continuous sound levels over a period of time. They do a great job with that. Where that slow response tends to fail sometimes is when we're in a situation, well, like what we're discussing previously with weapons fire, with impact noise, with noise that starts very quickly and ends very quickly and is very loud when it's on. Hammer and steel, those kinds of things, impact noises, are not necessarily very well captured using that slow response. So when that parameter is the parameter, or those environments, those conditions are the parameter of interest, looking at the LZPK, which is the level, Z-weighted or unweighted, PK indicates peak, that basically takes the highest sound out of that impact noise and records that. It records just the loudest that it ever got. That's what's recorded in that L peak. OSHA's limit for L peak is 140 decibels. There are some hearing conservation programs in some parts of the world, and some people in the U.S. have adopted programs where they will permit a certain number of these peak values at different levels. You know, I might be able to have 100 peaks of 115, but only 50 peaks of 120, and only 25 peaks of 125, those kinds of things. But the peak is designed to capture the highest instantaneous, immediate sound in that measurement period. So it's very possible to look at a measurement at the end of the day and have an L average of 87 and a TWA of 86 and an LZPK, a peak value of 115 or 120 from that one time when we dropped the hammer on the anvil, from that one time when the gun went off, from those kinds of impact noises. So that's basically what the peak value is for. Capture the highest, fast, unweighted sound that occurs during the measurement period.
Question about how does the MSO rule compare to the OSHA rule? Are there different action levels?
The OSHA rule and the MSO rule are very, very, very similar. All of the numeric criteria, that is to say, the program starts at 85 decibels time-weighted average, the permissible exposure limit is 90 decibels time-weighted average, are the same. They both use a 5 decibel exchange rate with the assumption that the damage that noise does to your ears doubles every time the sound level goes up by an average of 5 decibels. Probably the biggest place where there's a difference between OSHA and MSHA is that MSHA actually wrote into their regulation a requirement for dual hearing protection with a time-weighted average of 105 decibels. And I guess that stuff actually goes on once you get underground there in those confined spaces. Those kinds of sound levels are not uncommon. So what do we mean by double hearing protection? We're going to take a set of ear muffs. We're going to put it on over the top of a set of ear plugs. So dual hearing protection required at a time-weighted average of 105 decibels. There are also some subtle differences about postings. MSHA requires that the mine operator post their plan for engineering controls, their plan for administrative controls on the mine safety bulletin board. That's something that doesn't exist in general industry, and OSHA doesn't require that. There are other little subtle differences, but the biggest one is probably that requirement for dual hearing protection at 105 decibels time-weighted average.
Believe it or not, I think we made it through most of our questions. So thank you all for dialing in. I hope this was informational. I hope this was worthwhile. Again, we'll have this recording available on our website at raco.com/training. Again, if you're interested in learning more about the courses at the end of the month, question, we're going to do the ABIHA CM credits. Yeah, we have offered a credit for the regulation part, so yeah, there's credits that are available for attending the seminar at the end of the month. Again, you can email me at tom@raco.com. I'll get you more information about getting you signed up. If you have any other questions, you can also send them there as well. Lee, thank you so very much for joining us, for leading this today. Very informative, very helpful. And stay tuned for our next webinar. Will probably be later this month or early July. We'll be sending invitations out for that as well, so hopefully it's something that'll be worthwhile. And I guess that's about it. We're going to wrap up.
Thank you all for being here. I appreciate it very much.
Thank you. All right. Afternoon, everyone.